So welcome students. In this question you're given that f of x is 0 to x root t sin t dt. And you're asked to analyze for extremas between x going from 0 to 5 pi by 2. So if I want to analyze the local extremas, that is local maxima or local minima, I need f dash of x, right? So f dash of x is nothing but the differentiation of this integration. D by dx of integration from 0 to x root t sin t dt. So now how do you do the differentiation of integration? We use Leibniz theorem. So I hope you know how to use Leibniz theorem. So that is equal to, so first you just need to put x in the place of t, that is root x into sin x into the differentiation of x is equal to 1 minus, I just need to put 0 in the place of t into differentiation of 0. So that term will become 0. So f dash of x is equal to root x into sin x. So between 0 to 5 pi by 2, f dash of x is equal to 0 implies root x times sin x is equal to 0. So between 0 and 5 pi by 2, where will sin x be equal to 0? This will not be equal to 0. So this implies x is equal to pi comma 2 pi. So these are the two values where f dash of x is equal to 0. So now to see which of this is the local x maximum and which of this is the local minimum, you just need to do the double differentiation of this. So f double dash of x is equal to, so you use UV method. So root x times cos x plus sin x times root x differentiation is 1 by 2 root x. That is equal to, if you take the LCM, 2x cos x plus sin x divided by 2 root x. This is f double dash of x. Now what is f double dash of pi? If you take f double dash of pi, you get 2 pi into cos pi is minus 1, sin pi is 0 by 2 root pi, which is negative. So f double dash at pi is negative. This implies at x is equal to pi, you have a local maxima. So pi corresponds to maxima. And what is f dash? F double dash at 2 pi is equal to, so this is 0. So 4 pi into cos 2 pi is 1. So 4 pi by 2 root 2 pi. 4 pi by 2 root 2 pi, which is positive. So double differentiation is positive, hence you have minima at x is equal to 2 pi. So that will be the answer to this question. Thank you.